Thank you so much. So I should tell you guys a little bit about my background. I studied computer science, economics, and dance at Stanford University. So that was my third degree, dance. Worked at Microsoft, worked at Oracle. BeyondCore started out of some research I'd done with Clay Christensen. How many of you have read Innovator's Dilemma? Or whenever we say innovative technology or disruption, Clay's research is what you're referring to. So he was my faculty sponsor. To the point you brought up, we didn't realize how hard the research behind this was going to be. So it was 8 years of research before we could get VC funding about 2 years back from Menlo Ventures. And then Ray Lane, the former chairman of HP, president of Oracle, has become an investor. And we at this point have 25 of the Fortune 500 using BeyondCore. One fun thing that happened, we just made the Gartner Magic Quadrant as a visionary. The reason it's fun is only 24 companies get to be on the analytics and BI company. So we managed to kick out Oracle and a few other really huge ones to make that spot. So for a small company, it's kind of fun to do. The basic premise behind BeyondCore is something that every time you do analysis today, what you're doing is you're fundamentally asking a question. So the things Veronica was talking about are fundamentally about asking a well-defined question, then letting software give me the answer. Is that fair? Well, the problem becomes, have I asked the right question? And human beings actually suck at asking questions. Why do we suck at asking questions? We go where our biases are. We don't do very well-defined questions. We ask vague questions. Once we get a good answer, we stop. We are not very good at asking questions. Computers are really good at asking questions. But the problem with computers are, they don't understand our world, right? So we spend a lot of time trying to teach computers our world. That doesn't work very well either. So we said, let's flip this on its head. Is there a way to automate analysis in such a way that computers can ask all the questions on our behalf and make the results so simple to understand that people can overlay human intuition and domain knowledge? Because now you're leveraging the power of computers, the combinatorics of computers, but you're leveraging the human intuition and domain knowledge. That combination should work. That's what our work was all about. So I'll give you, before I go into too much, what exactly is analytics? This is my definition, and if you guys don't agree, let's debate this for a second. I see it as three things. What's going on in my data? Second thing is the pattern actionable? To many of the things Veronica was talking about is really separating something that's visually obvious from something that is actually actionable. It's not because of some accidents in the data. We'll come back to that. And finally, how do I explain it to people? Does this sound fair to people? What am I missing here?
Do I have the right data in the first place?
Interestingly enough, we always start with data. That's a data-centric thing, right? And I'm actually going to tell you that's the wrong approach to the problem. Because what happens is the moment you start with data, and we get data obsessed, you will spend several months trying to clean data. Then you're going to try to run an analysis. By the time your data is stale, you go back in with, it just becomes like really heavy lifting with a lot of work up front. If you flip it on its head, what you say is, what's a business outcome I want to change? So I have a revenue number I want to impact. I have a cost number I have to impact. I have a risk number I have to impact. Fundamentally, business runs on those three kinds of numbers. And now you say, OK, I want to impact this. What data do I have easily available? Before we start on what's the right data, you say, what's easily available? OK, let's analyze it and see how these variables are impacting this. Interesting part of doing analysis, I'm actually going into something that we were talking about earlier. Stepping back, there are 4 kinds of analysis. Have you guys gone through this? Descriptive, diagnostic, predictive, and prescriptive analysis? Have you guys gone through this? OK, so descriptive analysis is what is happening. OK, and that's what people do when they go into Excel and draw a graph, do a pivot table. If you're using Tableau, that's what you're doing. Next step is diagnostic analysis. Why is something happening? Have any of you done a component driver analysis by any chance? Where you're desegregating out the effects. Again, attribution models would be something like that. You're trying to understand why something is happening. Okay? Third level is predictive. What will happen? Fourth level is prescriptive. What can I do to impact change? Now, interestingly, if we start using all 4 pieces together, when you do that first analysis, what you're going to find is diagnostic analysis will tell you you don't have the right data. It's going to come back and say, the data you have given me does not explain your behavior. So now you sit there and say, okay, what more data can I add to this? Or descriptive analysis will come back and say, well, when this variable is unspecified, you have a lot more revenue. And you sit there saying, shoot, I need to go clean that up. I'm not collecting the right data there because clearly this variable is important and I'm leaving it blank a lot of the time. And when I leave it blank, there is an impact there. I need to clean this up. But if you were leaving something blank randomly, there won't be any pattern there. So diagnostic analysis is not going to come back to you and say, hey, there's a pattern when this variable is blank. So today we go with a very, think of it like how we used to build software in the old days. We would have a waterfall approach, right? We would write a really good spec. Then we would go write a really good piece of code. Then we would do a great job of QA. And after 4 months is done, 5 months is done, we find the customer didn't care about it. Everybody remembers this world? What do we do today? We move to Agile, right? What you do is you do something good enough, go back to the customer, show them, saying, is this right? What would you like to change? Okay, now I'm going to go rev it. I come back 2 weeks later. Do you like this? Why don't we do that in data science? Because we have been told to start with the data. I actually will challenge you to always start with the business outcome that somebody's trying to change. And use these methodologies as a way to, like almost as a metal detector, to figure out what data should I clean? What data should I add? How should I change my thinking? Does this resonate? Does this make sense? Okay. Any other questions? Anything else that you think I'm missing here, broadly? Okay. So let's take the first one of these, asking the right question. So quick question, if I have 10 variables in my data, how many different types of 1, 2, and 3 variable graphs can I draw? A ballpark number is okay. So 10 one variable graphs, easy. 92 variable graphs, 723 variable graphs, so 820 graphs, right? Is this fair? And I'm not distinguishing between orientation because I'm saying gender by state is actually different from state by gender. When you look at the graphs, you'll see they're kind of, visually they look different. But here's a bigger problem. I didn't talk about drill down graphs, right? Let's say there are 10 possible values to each variable, right? I'm looking at state, and there are 10 states. How many graphs could I draw if I start drilling down, if I start zooming in on California only? How many graphs would that be? Give me an order of magnitude.
10 times.
So 10 times for one variable, 100 times for 2 variables, 1,000 times for 3 variables. You're basically in the domain of about 1 million graphs if you have just 10 variables in your data with 10 values per variable. And most people have more than 10 variables in their data. And most people have more than 10 values for most variables. So why the heck do we start with the data and why the heck do we start with questions? You see where the problem is fundamentally? How do you solve this problem? Anybody who's doing predictive analytics where you do kitchen sink regressions? There are ways to do this in the world of predictive analytics where what you do is you throw everything in and you say, give me a model. Or machine learning tends to do that to some extent. But those have fundamental problems as well. In a kitchen sink regression, the order in which I add a variable matters. So if only young men have motorcycle accidents, if I add motorcycle in first and then I added age and gender, motorcycle will show up as not being important. But if I had already added age and gender, then added motorcycle, it'll show up as being important. But we're already getting into advanced analytics. Most of the world doesn't do advanced analytics. They just draw graphs. How are they going to solve this problem? So you guys are now going to help me solve this problem? Because without this, this doesn't solve. This doesn't work, right? So we were working with McKinsey, and we looked at 30 million patients across 1 million variable combinations. So what they were trying to do is they were trying to figure out what drives readmission rates in hospitals. The issue there is there's so many different questions I can ask about the data. Now, let me tell you that in general, actually, let's ask you guys, who do you think has high readmission rates as a segment of the population? Go ahead. Cardiac patients, that's a great answer. Give me another answer. Old people. Fair? All chronic diseases, but in general, old people have high readmission, right? Chronic diseases have high readmission. So if I asked you to look at that data, most people go in and say, I'm going to look at cardiac events. I'm going to go look at things related to old people's diseases. Because that's a Willie Sutton rule. You go where the money is, right? In this case, old people have high readmission. I'm going to go there. Would you ever look at young women? In general, by the way, women have lower rehospitalization rate than men. I see one woman in the team, this is a problem with data science. There needs to be a lot more women in the teams. But what happens is women are much better than men at taking meds. They actually are. It's like you can scientifically look at the data and it's obvious that women are better. And young people obviously have low rehospitalization rates. So would you look at young women? No. And that's exactly what happened. Nobody in the healthcare space had looked at young women. One of the patterns BeyondCore found was when you look at diabetic ketoacidosis, which is the form of diabetes, young women had a 49% rehospitalization rate. Right? That's a shockingly high number. 49% rehospitalization is a ridiculously high number. Why is it that everybody missed it? Because of the problem we are talking about. Anybody wants to guess why young women would have a 49% rehospitalization?
Vanity.
How did you get it? Have you seen my talk before? Okay, people really had a hard time with this. Okay, explain your answer. You said vanity.
Yeah.
Explain, yeah.
They don't want to prick their finger because I don't know, right?
Oh, you went in the right direction, then you veered off. No, it was not because of pricking of fingers. But it is related to vanity. I thought you, for the first time in 3 years talking about this, I thought somebody guessed it right the first time. Try somebody else, try. What happens if you don't take insulin? Your body doesn't process sugar, so you lose weight. It was a dieting strategy. So once the pattern was found, they went in and talked to the doctors, and the doctors figured out, oh shoot, the reason these young women are having such a high readmission rate is because they're dieting by not taking their meds. And by the way, young men have a slightly high rate too. Okay, 28% is not very low. Now this becomes the chicken and egg problem. In traditional analysis, you will find the right answer if you already knew the right answer. Because you have to ask the right question to get the right answer. How do you know the things that you don't know? And if the things everybody knows was the important thing about your data, you don't really need any analysis. Your competitors are doing the same stuff. How are you going to have a competitive advantage? That's the fundamental flaw in analysis, having to start with a question. The second problem, though, is I may show you a pattern that is visually really attractive. Veronica was talking about promotion effectiveness. Let's say I give you a promotion that looks really effective. But now I tell you that promotion was disproportionately run in November or disproportionately run in California. Now what do you say? You say, well, I have to adjust for the Thanksgiving effect and have to adjust for the income level of California. Fair? So just looking at a pattern is insufficient. When we say statistically validating the pattern, at a very basic level, we are talking of something like a t-test. How many of you are comfortable with a t-test? Okay. The way I always explain it is, and this is maybe an oversimplification, is if the only Chinese person you knew was Yao Ming, the really tall guy, and the only American you knew was Danny DeVito, do you decide that Chinese people are taller than American people? Right? How do you decide that? Is that a sufficient sample size? Or if I'm looking at, is it worth to invest money in Omaha, and I look at the average income level, do I include Warren Buffett in it or not? Right? These are fundamental statistical questions. But what happens today is people look at a descriptive graph without thinking of the fundamental statistical questions. And today there is this, when you point this out to people, they'll say, but I'm not a data scientist. I'm sorry, if you're drawing a graph, you're a data scientist. It's your job to get the answer correct. So you have to look at these statistical things. Next level up would be a component driver analysis. Desegregating the effect into lots of different pieces. This part is because of the promotion. This part is because of the promotion in November. That part is because of the promotion in California. Does this make sense? So I'm going to give you a real example. And shockingly, by the way, I cannot believe this, but this actually is a real example. One of the larger banks in the world, they had done an analysis on where do they have a lot of mortgage defaults, right? Where do people not pay their mortgages? And they figured out they were doing really badly in Arizona. And I used to joke before I realized this is actually what they did. I said, so what did you do? Stop making loans in Arizona? And the guy said, yes, that's what we did. We stopped making loans in Arizona. What else can you do if this is all you know? What would you want to know, guys? And I use guys in a gender neutral way, so please do chime in, okay? What would you want to know? Is this sufficient, firstly, for a business decision? Then why the heck did we draw this graph? Now, if you do a diagnostic analysis, what you find is Arizona had 50% higher proportion of manual approvals of loans. Loans are usually automatically approved. Let's say across the country, 4% of loans are manually approved. In Arizona, 6% was getting manually approved. I also tell you that the decile with the lowest FICO score, so people with the lowest FICO score, that decile was more represented in Arizona. So Arizona had more people with the lowest FICO scores as a proportion of the population. Please.
So, question about feature selection, because in order for you to spot these patterns, you actually have to have that feature in the data. And, you know, so then you're back to sort of the kitchen sink model where you're just going to take everything that you have. For instance, there's an example that I've used in class where a friend of mine identified that people who made job applications on Safari were better than those making job applications on Internet Explorer. But the only way they could have recognized that is because they actually had a column for every individual applicant which coded the browser they were using. Now, who would ever think to put that in? That was just an automatic entry. So if you have manual approval versus non-manual approval, somebody has to think that's relevant.
Right.
And included in the data that they're doing the analytics on.
Absolutely. Back to the point I was making earlier. When you make analytics really, really simple, so in this case, it was 100,000 combinations that was evaluated in 2 minutes. Firstly, what happens is people can throw whatever the heck they want at it, right? Because my cost of adding a few more variables doesn't matter, right? But secondly, and because of the way this is set up, I can't bring up my product and show it to you, so we can take this offline and show you. You're going to get an unexplained part, where BeyondCore is going to come in and say, under these circumstances, something very strange is happening. Now it's up to the human being to sit there and say, why this specific case? Why is BeyondCore flagging this specific case as being something that is a high unexplained? And then they brainstorm and they say, hey, are we doing more manual adjudication? Aren't those the characteristics that causes us to do exception handling? Let's put in manual adjudication as the thing we'll put in. I'll give you, actually step back, I'll give you a real story this happened. We were looking at hospital excess stay, length of stay. And we first did an analysis and we showed them that one hospital in Detroit for tracheostomy, people were staying much longer than expected. And there was a huge unexplained bar. The hospital administrator steps back and says, you know, the reason people often stay at hospitals longer is because of hospital-acquired conditions. Did they get infected in the hospital? Okay? So they added in one more column called HAC, hospital-acquired condition. And it turned out it did not change the unexplained pattern. Now the guy says, well, you know what, hospital-acquired condition is something that a doctor decides. They sit in a room and they decide, was this a hospital-acquired condition? But whenever I have an infection, I have to give them antibiotics. So let's add the amount of antibiotic prescribed to the data. And antibiotic use perfectly explained the outcome. Now you've learned two very important things. Firstly, these people actually had an infection at the hospital, which was causing them to stay longer for that specific treatment. But you also learned that doctors are not marking things correctly as hospital-acquired condition. But what this does is it turns it into an iterative, information-driven approach, rather than today where we have to figure it out up front. When the iteration is 2 minutes, at the Gartner conference, this guy from First Interstate Bank brought up his user screen on stage, right? And he said, if you look at my iterations between each analysis, it's 4 minutes apart. So I did an analysis, I found a problem, I pulled in data from a different data set, I reran the analysis, and I brought up my new report, and 4 minutes later. When the iteration time is down at the level of minutes, you don't have to get it right the first time. All you need to know is I'm going to keep iterating, get signal from every little step, and make my analysis better. Back to agile versus waterfall. Did I answer your question? Cool. But back to this point, once I give you this information, would you say Arizona is different? Yes, I have an adverse selection problem here. There are things that are independent of what Arizona is that occurs more often in Arizona. So, and what happens with the low FICO score people? These are the people we have charged a higher interest rate for, right? We've already decided that they're going to have a higher default rate, so we have charged them a higher interest rate for it. Then why am I graphing it and not considering my adverse selection problem? This is where analysis breaks apart, where people do a descriptive analysis, a visualization, and don't do a diagnostic analysis. Any questions, comments on this? This is actually crucially important for you guys to get, because every time you see a graph in a normal BI product, you should be saying, but why? This is just giving me the what. But has the statistical test been done? Why is this happening? Without the why, the what is useless. Please.
It's interesting because I think a lot of times there's a good reason why this is the case, because you're trying to sell a company. Because you're trying to say, well, this is what I think you should do, rather than really get to the heart of what maybe you really should be trying to get to the heart of.
So I'm going to give you the more cynical version of the question you asked. This is the reason I did not actually join a consulting firm. I was talking to one of my favorite consulting, I went to Harvard Business School, which is like a third of the people there are from the top consulting firms, and I think the third of the people leave to go to top consulting firms. And I asked this guy, what does the engagement look like? And he was like, often enough, the engagement starts with the partner coming in and saying, here is what the answer is going to be. Now do all the analysis, and I want to see that's what the answer is going to be. And yeah, 70-80% of the time, that's perfectly fine. Maybe because of your years or experience, you know what the answer is. But is that really analysis anymore? That's justification of a conclusion based on the data, and the moment you get something that indicates that's justifiable, you stop. Data analysis has to be broader than that. Data analysis has to be about letting the data speak, not torturing the data into confessing. There's actually a company out there that is proud of it. They have a t-shirt which says, we torture the data into confessing. I asked them for a t-shirt. I was like, I really want this in my room. And they didn't understand why I wanted that, because I was like, are you guys crazy? You're actually proud of the fact that you can torture the data into confessing everything. That's not analysis. Please.
So in a case of healthcare example, you found one diagnostics case, which there could be also an argument that medicine will not conclude that that solves the issue.
Right.
So there could be a bunch of other underlying, many variables that are the reason why somebody stays an extra day.
Absolutely. The diagnostic, the unexplained part doesn't go to zero. It never goes to zero. But what happens is, if most of my stuff is off by 0.2 days, and I have this one case in Detroit for tracheostomy where the unexplained is 3 days, you definitely want to add variables, and that 3 days doesn't go down to zero. The 3 days would come down to 0.4 days of unexplained. You will have some randomness in your data, right? In fact, one interesting thing is if your unexplained is zero, I can guarantee you have overfitted your model. Your model is now so complex, it is perfectly fitting the data, and it's going to run into real trouble when you do a validation. A good model will always have a certain amount of uncertainty. Does this make sense to people? Have you guys done the k-fold validation stuff? So one of the things we do is, after a model is created, you do a stepwise reduction to make the smallest model possible for efficiency, and you do a k-fold validation to make sure the model actually is not overfitting. But you can do that automatically. That's math. That's not hard stuff. Once something is math, you can teach a computer to do it. You can actually teach a computer to do it far more accurately than you can teach a human to do it. What you cannot teach a computer is human intuition. So when we did the healthcare one I was talking about, one of the things BeyondCore got very excited by is that only women get pregnant. It happens to be a fact of the data. When you look at healthcare data, yes, only women get pregnant, and it actually has excess length of stay implication. As a human being, what do? You say, yeah, I knew that. Let's move on to the next pattern. Does this make sense for people? Or you might go and say, oh, wow, this is really biasing stuff. I'm not going to put in pregnancy-related diseases. But that's a decision a human being has to take. The machine will learn a pattern, and then you have to figure out why that's happening. Human interpretation cannot be taken away. Does this make sense? So if the clicker works, if the clicker does, okay, finally. Explaining the story. Have any of you guys created a dashboard like this? Okay, the real one was actually 36 pages long. Now, why would you have a dashboard like this? Why do you end up with something like this?
I used it in customer service data.
Right, but the reason you end up with a dashboard like this is somebody at some point created a nice dashboard. And then one guy said, well, what about this graph? Another guy said, well, what about that graph? Third guy said, what about this other graph? So you go add those 3 graphs, and you go back, and he says, oh, what about this other graph? And nobody says, take this first graph out. So you end up with a superset of everyone's requests. Is that fair? But remember what I showed you at the beginning? There are millions of possible graphs. So it's an impossible approach. But that's what people end up with. And then what happens? Have you guys seen this happen? This is really cool. So you'll see a 36-page graph, and then you'll see marking saying, these are the ones my boss looks at. And there are like 10 graphs marked off. And these are the ones that the VP looks at. And there's like, you end up with these hierarchies on top of the dashboards because people realize you can't look at 36 pages of graphs. Now let's move into the world of predictive analytics. Anybody here has seen a scoring system? Like in Salesforce, for example, you have scoring systems which say, this is a good lead, this is a bad lead. The problem is, all it will tell you is, this is a good lead. How's that useful? Because I don't know why that's a good lead. If I'm a sales guy, what do I say? I have 10 years of experience. I don't care you think this lead is good. I know better than you whether this lead is good or not. The explanation is lost. If you want to tell a story, there are actually 3 parts to it. One is there's a visualization. Yes, the visualization needs to be there. But there has to be an explanation. Why is this happening? And there has to be a math part to it, the prediction. In this case, we are predicting what would, actually this is a diagnostic graph. So what would happen if I change a promotion to quick start for a certain competitor? And it's first going in and saying, well, this is the baseline for competitor today. This is the part that would be because of this promotion change. This is because of the promotion change in general. But also what happens is this promotion, this competitor shows up a lot in Latin America, and it turns out this promotion is more effective in Latin America. So you have to start explaining why you're making the recommendation you're making. Does this make sense to people? So the story, and this word is getting overused in the space a lot right now. If you go and talk to Tableau and ask what a story is, or ClickView and ask what a story is, it's a picture and some text. That's not a story. A story is an explanation for what's happening behind, explanation for the math. It's not showing you a graph of promotion and saying this is the graph of promotion and this bar is high. I don't need text to tell me that. What I need text for is, hey, here's your graph by promotion. This promotion was run mainly in California. That promotion was run mainly in November. You need to be aware of these facts. That's a story. That's an explanation. Does this make sense for people? So anybody here wants to do a machine learning startup? Easiest way to get funding nowadays. If you have some background in machine learning or artificial intelligence, you're going to say I'm a machine learning startup, you get it. Because VCs don't know what machine learning is 80% of the time. That's part of the problem. Okay? So what happens with machine learning? You're teaching a computer how to conduct analysis. Now, none of you are old enough to remember this time, but there was a time in the 1970s when something called expert systems were going to take over the world. Any of you have heard of expert systems? So Ed Feigenbaum wrote a great book on how Japan was going to destroy America because Japan was ahead of the US in expert systems. And expert systems were objectively more accurate than humans. The reason they didn't catch on was because expert systems were magic answers. They wouldn't explain why something was happening. And what happens for a human being? Human being says, I'm not going to take a risk based on that answer. I don't know why you're telling me this answer. All the technology changed hasn't changed human nature. Human beings still want to know why. Does this make sense? And that's why this human comprehension gap, how does a human understand analysis, is actually as big, if not a bigger problem, than how do I teach a computer how to do analysis. In fact, by the way, this piece is becoming commodity extremely fast. Google has open sourced it. There's some really cool projects out of MIT and Stanford that are open sourcing this. Microsoft just got forced into open sourcing it because Google went open source. Microsoft had done some other stuff open source already. This is geek stuff. This will get open sourced, right? In fact, think about technology in general. Any technology that is used mainly by geeks always succeeds as open source. Linux succeeded with the geeks. It didn't succeed with my mother, right? When you go to human experience, open source projects do horrifically badly. Can you guys tell me of a single open source project that's really useful for an end user? I can't think of one. The reason is the people who are in the open source group, fantastic brains, fantastic people, but they're building for other people like them. That's a very valuable technology. But what you need to have is this piece. And the open source community doesn't think that way. They're not focused as much on human interaction, human comprehension gap. That solution is what's going to bring analytics to everyone. Questions, comments on this? Now, because I can't show a demo, I'm going to do something I never do, which is show you guys a video of how we have solved this. If you don't mind playing the video, that would be fantastic. But you guys can catch me afterwards and I can show you the stuff for real. But I wanted to show you what I meant by taking descriptive, diagnostic, predictive, and prescriptive all together and turning it into something a human being can understand. So what you're about to see is a data set. The next slide has the link. What you're about to see is a case where we had data from Salesforce and data from Marketo. So we had some promotion data, we had some sales win data. Yeah, we had some sales win data. And we wanted to understand what was driving our win rate. Does the problem make sense? Okay.
You need audio?
Yeah, I do need audio, but I think when she plays it, it should show up. If you hit the play. Just ignore the flash screen. Sorry, I should have edited that out.
Maximize win rate in sales opportunities.
Could you push up the audio?
I detected a variable called win in dataset sales opportunities. Click begin to start the analysis.
It's figuring out where the data is for sales opportunities and try to analyze it. And setting up an analysis for me, and then it goes in and hopefully the
Analyzing the dataset sales opportunities to explain the behavior of the variable win. There are 2,937 possible graphs and drill downs in your data. Now evaluating every one of these possible graphs.
This is where it would
Now
do the t-test
statistically
and R-squares
evaluating
and
every
things like
insight
that,
to
the
make
statistical
sure
test.
they are actionable. Finalizing the executive briefing for you.
And the first part it's going to go into is descriptive and diagnostic, not just descriptive.
On average, a lead has a 26.6% win rate. However, the win rate is higher than usual when region is Latin America. This is because of the following key factors. Product laptop has a higher win rate in Latin America than in other regions. Promotion quick start has a higher win rate in Latin America than usual. Competitor Fablo, which is associated with lower win rates, occurs less often when region is Latin America. The rest of the difference is explained by 336 other factors, which contribute the rest of the difference between Latin America and the overall win rate.
Now I can go into other stuff. I want to see Brazil, or I want to see some competitors, etc. Otherwise, it's going to move me to what has changed this week. Once again, data is
Win
never
rate against
static. It's
TikTok
constantly
went up
changes.
last week. It went up more than most other competitors. This is a continuation of a long-running trend. BeyondCore forecasts that the win rate will rise again next week.
And once again, now you're finding what's the next most important change in this time period. Because change is going to be constant. And now you wonder how to increase revenue.
BeyondCore recommends that promotion be changed to quick start for all leads where competitor is Fablo. We expect this action to increase the success rate to 22.2%. Changing promotion to quick start will have a strong positive effect across all Fablo leads. Changing promotion to quick start has a small positive effect across all leads, whether competitor is Fablo or not. Fablo has a high frequency of leads where region is Latin America. Unchanging promotion to quick start has a large positive effect under these conditions. These effects combine with 127 smaller effects to produce the predicted improvement.
Now, I know what you're going to ask me is how did we avoid the A/B testing, right? Because I just did a prescription without an A/B test. Now, what we are saying is there are accidental experiments in your data. You had situation where the competitor was the same. Oh, yeah, sorry about that. The competitor was the same, but I used a different promotion. Or the competitor was the same, but I had different geographies. Does this make sense? So what you do is you start creating an accidental experiment approach to this. Instead of trying to create a perfect randomized sample, you say, look, there's no such thing as a perfectly randomized sample in the first place. So why don't I start doing mathematics to statistically back out from accidental experiments?
Now, in order to get rich data that way, would you want to instruct your sales team to, behave more randomly and kind of, roll the dice before they make a phone call, that sort of thing?
So
Generate some variety in the data?
So it turns out in most real world cases, we restrict it to at least 10,000 rows of data. So we don't do it if you have 5 rows of data. So if you have at least 10,000 rows of data, there's enough accidental experiment. And BeyondCore does flag cases where things are just always occurring the same way. So then you would go in and say, oh, I have not, like we had a case where they had always had the same discount rate and they wanted to have a discount analysis. I'm like, look, you've had the exact same discount rate for 7 years. There is no information here to do any analysis. So you got to now start changing your discounts a little bit to do that. But in a real world case, there'll be enough accidental experiments and then some cases where there are no experiments. And you flag that and say you might want to experiment. But what is important here is instead of having the human being do a lot of work up front, you are forcing the human being to look at that prescription and say, does this prescription make sense to me? Right? And they might then say, oh, I want to now do a control experiment to really test it out. But instead of all the heavy lifting up front, that was actually a case of going from raw data to a set of information that's useful and interesting. Now I can iterate. Now I can add in more data. That's what I mean by letting computers ask the questions and let humans interpret an action.
So most companies now have data science initiatives. Most of them are hiring data scientists. And then the struggle that they're mainly faced with is how do they incorporate the data scientist into the decision-making process. And so the big debate is, do you have the data scientists initiate business decision-making, or do the business decision-makers then go to the data scientist with a specific question in mind? So would the kinds of products that you see being developed, like BeyondCore, how would that sort of fit into to this flow of decision-making? Is it sort of meant as a way for people to kind of minimize the need for the data scientists? Is it a way for them to kind of jumpstart a conversation with the data scientists?
Right. So I would put it a couple of different ways. First, let's start with the data scientist. 80% of a data scientist's time goes into boring stuff that they know could be automated. And they always have a large number of projects. Whoever is the data scientist in the room, you're nodding your head. It's a standard problem. It's not like that. It's not like they're sitting there with a lot of free time, right? Second part of the problem, the place where most analytic projects fail is a business user, you're going to be my data scientist, okay? I go in and ask you for a problem. You go away for 3 months and you come back with an answer. By that time, that question is no longer relevant to me. That question was relevant then. 3 months later, I have a completely different set of questions, right? So what we are trying to change is a different approach to this, where you empower the business user to be able to do basic analysis very, very fast, right? What's impacting my revenue? What's impacting my cost? What has changed? Things of that nature. There will be deep analysis that gets triggered from this. The deep analysis you will need a data scientist for, right? If you're going to really complex affinity analysis, for example, you're not going to be doing that through a completely automated system because that requires a deep understanding. But when you can automate away 80% of the problem, now the remaining 20% is really the deep thing that a data scientist needs to focus on. The parallel I draw is when the heart stent was first introduced. I don't know whether you guys know this. You put a stent in the heart and the blood flow works better, right? The cardiologists were very opposed to it because they thought, what the heck, this is going to kill our business. What actually happened was stents brought down the cost of heart surgeries, brought down the risk of heart surgeries, and people did a lot more heart surgeries. And then when the remaining really hard problems came up, the cardiologists could charge a lot more to do that. Cardiologists made more money because of stents than they did without stents. But the population as a whole got much better off because they could get safer, cheaper, faster heart surgeries. That's what we are talking about. It's not an either or. This is the iPad, you'll still need the supercomputer. But 80% of the people will need the iPad. Any questions? What do you want to challenge me on? I'm sure that was, and actually at the end, I don't know whether you saw this, at the end we had a link for Salesforce. So you could click a button and push that model out to Salesforce. So that in Salesforce, when you're looking at a lead, you don't just see the score of the lead, you see the explanation for the lead. And you can say, what would happen if I change promotion? And you get an immediate update of the lead and the scoring and stuff. So how do you take this to operational systems, was something Veronica was talking about earlier, is you want to have this analysis running all the time because your customer's behavior changes over time. It's not static, right? So how do I make sure that as my customer's behavior changes, my model changes? How do I make sure when the salesman wants to go in and say, what would happen if I do this? It gets answered immediately. That's operational analytics, something that's used every day. And you cannot have data scientists stand next to a person every day and do stuff for them. You have to automate it. And you can't do it by saying, here's the answer, you're too stupid to understand why that's the answer. It doesn't work. You have to say, here's the answer, and here's why.
Okay.
Thank you.
Thank you, Arjit.